In this video, I will walk you through problem number 4 from the 2012 AP Calculus exam. The function f is defined by f of x equals the square root of 25 minus x squared for the closed interval from -5 to +5. Part A, find f prime. Well, let me start by rewriting this slightly as 25 minus x squared to the 1/2 power. We will find f prime using the chain rule. First, the outer function, the power rule, tells us we will have 1/2 in the front, and subtracting 1 from the exponent gives us -1/2. On the inside, we still have 25 minus x squared, but because we have a function inside of here, we will multiply by the derivative of that function. The derivative of 25 minus x squared is -2x. So now I have f prime is equal to, I'm going to go ahead and put the negative in the front. 1/2 of 2 is 1. So basically the 1/2 and the 2 cancel each other out. I still have the x though. So I have -x times 25 minus x squared to the -1/2 power. You are welcome to leave your answer like this for a free response question. But just in case in the future we have this as a multiple choice question, I'm going to show you a couple other forms. So you see the negative exponent here. So that means I could take this expression, the parentheses, and the -1/2 power, and I can drop it all down to the denominator. In the denominator, it will now have a positive exponent, so I could have this. So here is another valid answer. And one more, the 1/2 power is the same as the square root. So I could write f prime is equal to -x over the square root of 25 minus x squared. Part B, write an equation for the line tangent to the graph of f at x equals -3. I love it when they ask me to find the equation of the tangent line. I always use point slope form because this reminds me that all I need is a point and the slope, and if I have those, I can write the equation by doing y minus y1 is equal to the slope times x minus x1. This is point slope form. Let's start by finding the point of tangency. They gave us the x coordinate, -3. All I need is the y coordinate. So I'm just going to take this -3 and substitute it into the original function. In other words, we need f at -3. So that will be the square root of 25 minus -3 squared. -3 squared is +9, and 25 minus 9 is 16. So f at -3 is 4. So we have the point -3, 4. We have the point, now we just need the slope. The slope will come from the derivative. So we need to find f prime at -3. And remember, we just found f prime right here. I think I'll use this version right here. So I am substituting -3 for x here and here. And I'm getting this expression. Let's just simplify this. So f prime at -3 equals, the opposite of -3 is +3. And then in the denominator, this is looking really familiar. negative 3 squared is positive 9. 25 minus 9 is 16. So we have 3 over the square root of 16, which gives us f prime at negative 3 is 3/4. And this is the slope. So now that we have a point and the slope, we can write the equation. The equation goes y minus y1, so y minus 4, is equal to the slope times x minus x1. Minus negative 3 is plus 3. So this is the final answer. Part C. Let g be the function defined by g of x equals, well, all of this. Is g continuous at x equals negative 3? Use the definition of continuity to explain your answer. Here are some notes that you will need in order to answer this question. G of x is continuous at x equals negative 3 if the limit as x approaches negative 3 from the left equals the limit as x approaches negative 3 from the right, which equals the value of g at negative 3. So our strategy will be, let's find each one of these three values and see if they're all equal. Let's start by finding the limit as x approaches negative 3 from the left. Well, to the left of negative 3, we are in this interval right here. And the piecewise function says that in this interval, g of x is equal to f of x. So what was f of x again? It was the square root of 25 minus x squared. We can evaluate this limit by direct substitution. Just plug in negative 3 for x. So we get the square root of 25 minus negative 3 squared. Man, this is looking very familiar. This is the square root of 25 minus 9, which is equal to the square root of 16, which is equal to 4. This is the limit as x approaches negative 3 from the left. Now let's find the limit as x approaches negative 3 from the right. Well, to the right of negative 3, we will be in this interval right here. And according to this piecewise function, g is equal to x plus 7 in this interval. So we need to find the limit as x approaches negative 3 from the right of x plus 7. Direct substitution will work again. Substituting negative 3 for x, we have negative 3 plus 7. And that is 4. So far, so good. Both of these have a value of 4. And finally, we need to evaluate g at negative 3. Which one of these functions do we use when x is equal to negative 3? Well, you see the little or equal to line right here. If x is less than or equal to negative 3, we use this piece of the piecewise function. And x is equal to negative 3, so we will use f of x, which again is the square root of 25 minus x squared. And I'm going to skip a couple of steps, but let me just go ahead and do direct substitution one more time and just show this part. But we already know this is equal to 4. So notice how all three parts are equal. So we can go ahead and make our summary statement. You would say g of x is continuous at x equals negative 3 because the limit as x approaches negative 3 from the left of g of x equals the limit as x approaches negative 3 from the right, which equals the value of g at negative 3. This is the definition of continuity. Part D, let's find the value of the integral from 0 to 5 of x times the square root of 25 minus x squared dx. I've done two things here so far. I've rewritten the problem with a 1/2 power instead of the square root. but also I am intentionally leaving off the limits of integration. The reason is because I am about to do u-Substitution, and I don't feel like changing the limits of integration. So you must leave them off when you do your u-Substitution because these are x's, and once we switch over to u's, they will no longer be valid. You can just put them back in at the end when we turn everything back into x's. Scanning across this problem, I see this 25 minus x squared inside the parentheses. That will probably be a good u to use. We will also need u prime, which will be negative 2x. So let's go ahead and do the substitution. So we will have x times u to the 1/2 power. Instead of dx, we will write du divided by u prime, but u prime is negative 2x. Notice that we have an x in the numerator and an x in the denominator. These will cancel each other out. I have this negative 2 in the denominator still. When I rewrite this, I'm going to put it out front as a negative 1/2. See, it's in the denominator, so that's why it's a 1/2. So I now have negative 1/2 the integral of u to the 1/2 power du. So this is very doable. Using the power rule of integration, I will add 1 to this exponent. 1/2 plus 1 is 3/2. So I now have u to the 3/2 power. But then I divide by the new exponent. Dividing by 3 over 2 is the same thing as multiplying by 2 over 3. Bringing over the negative 1/2 from the previous step, I have this. And I'm going to temporarily put this constant of integration on here. Ultimately, I will not need this when I put the limits of integration back in. Notice that we have a 2 in the numerator and a 2 in the denominator. These will cancel each other out. So I'm going to end up with negative 1/3 in the front. So I think now is a good time to substitute for u, because u is 25 minus x squared. So let's go ahead and write 25 minus x squared again. Instead of putting the plus c, let's put the limits of integration back in by putting a vertical line, and you can just stick the limits of integration here and here. This reminds us that we need to find the value at 5 and then subtract the value at 0. So here is the value at 5, and here is the value at 0, which I am subtracting. Be careful because we do have this double negative here. I should point out to you that you could leave your answer just like this. This is full credit on the AP exam. However, I am going to simplify this a bit more, just in case we one day run into this on a multiple choice question. 5 squared is 25. So we have 25 minus 25 right here. That's 0. So this entire term is really just 0. And then we have this minus a negative. So this will be a positive. So really this will be gone. And then 0 squared is just 0. So that little term is gone. So we are left with 1/3 times 25 to the 3/2 power. You could certainly put this as your final answer, but we can simplify this even further. When you see a fractional exponent, the numerator is the power and the denominator is the root. So if you keep that in mind, I have 1/3. The 2 is the root, so that means I have the square root of 25. And then 3 is the power. I could have put the 3 on the inside right here, or I can put the 3 on the outside. I'm choosing to put it on the outside because I would love to simplify the square root of 25. Of course, the square root of 25 is 5. So I have 1/3 times 5 to the third power. 5 to the third power is 125, so I could also write this as 125 over 3. This is the most simplified version of the answer, and this is probably what you would see as a choice on a multiple choice question.